Good day, guys. You are welcome back to ID International Academic Mathematics class. I want to believe you enjoyed the last class. Today is going to be enjoyable as well. Let's move to the major thing in indices, and that is laws of indices. You've learned how to express numbers in index form, whether whole number or fractions. Now let's move on to learn some important laws that guide the operations in indices. So, number one of these laws is what I will call law of multiplication. Let me write it. In this law, Roman figure 1, if you have b raised to power x times b raised to power y, the product of these two index numbers will be expressed using the law of multiplication in indices, whereby when we have common base of two or more numbers and we want to find their product, we take one of the base, since the base is common to them, base b, base b. So multiplication sign will now change to addition in the exponential region, as in the power area. And that addition will add up the powers of the two of them. Am I communicating? So it will be b raised to power x plus y. That is the law of multiplication, which changes to addition. What if you have a number like 3 m raised to power 5 times 2 m raised to power, let's say, 3? The same law applies. You just first rewrite this as 3 times m raised to power 5 times 2 times m raised to power 3. The figures can be grouped together as 3 times 2 times m raised to power 5 times m raised to power 3. You can now see that m raised to power 5 times m raised to power 3 takes the picture and the format of Roman figure 1. So this one, 3 times 2, 6 times, you now apply the law in Roman figure 1. The process in Roman figure 1, apply it to this to have m raised to power 5 plus 3. So 6 times this gives 6 m raised to power 8. 5 plus 3 is 8. So that is how to simplify something like this. So that gives the basic rule of multiplication in indices. The next here is law of division. In this, division sign changes to subtraction. Don't forget, in the power region, in the power space. So, Roman figure 1, if you have something like x raised to power m divided by x raised to power 2. The law says if we have two or more numbers that are in index form or that could be raised in index form and want to multiply them together, if they have common roots, common base, we pick one of the common base, like as I pick x now. The division sign changes to subtraction in the power area to operate the two powers together, as in to have m minus 2. That's as simple as it is. That is how it is. Roman figure 2. Should we have something like 12b raised to power 3 divided by 6b raised to power like 2? How do we approach this? It's the same thing as having it 12 b raised to power 3 over 6 b raised to power 2. 12 divided by 6 gives 2. Don't forget, b raised to power 3 divided by b raised to power 2 is treated as b raised to power 3 minus 2. The reason is this. This division line will change to subtraction to operate the two powers. So it will now be power 3 minus power 2. So the result will be 2b raised to power 1, which is 2b. b raised to power 1 is the same thing as b, so 2b raised to power 1 is 2b. That is that about division law. Law number 3. Don't think in a way that always laws must be arranged as I arrange it for you. No. What I take to be law number 1 in my own class may be law number 3 of another person. What is important is you knowing the laws, not their arrangements. So, law number 3, law of zero index. This is to say that anything that is raised to power 0 is what we want to consider in this regard. We want to consider the status of something raised to power 0. To be straightforward with you, anything raised to power 0 equals 1. X raised to power 0 is 1. 3x y raised to power 0 is equal to 3x. Someone will say, why not outrightly 1? It's not going to be outrightly 1. Like x raised to power 0 equals 1. This one cannot be equal to 1. Because we have 3x and y here. Which if you separate them as 3 times x times y, it is only the y that is carrying the power 0. So it is only the y that turns to 1. So you still have 3 times x times 1, which gives you 3x. I hope I have clarified that. Good. So if you have 25 raised to power 0, answer is 1. If someone promised you last week that 2 months' time is going to give you like 250 million naira raised to power 0, the person has promised you nothing. Because the person will eventually give you only 1 naira. Someone that promised to give you 250 million naira raised to power 0 is only promising you 1 naira. Because everything raised to power 0 will give you 1. I hope you understand the concepts. So that is the concept. Let's move to another concept. The law of negative index. The law of negative power, so to say. Roman figure 1. X raised to power minus 2. Remember, it will be equal to 1 over x raised to power 2. You know, that is, we have used this before, even today. So it's like we are reversing it. So whenever you see a number with negative index and you want to operate on it, it may be necessary for you to turn it back to a number of positive index, which is this. What if it is a number like x over y, which is raised to power minus 2? It will be expressed as y over x. You find the reciprocal of x over y, which is y over x. And it will be raised to power 2, just 2. The negativity there disappears the moment you find the inverse of what is in the bracket. Am I communicating? So that is it. Example of this is when you are to simplify 1 over 4 raised to power minus 2. 1 over 4 raised to power minus 2 will be expressed as 4 over 1. 4 over 1 is 4. 1 over 4, inverse of 1 over 4 will be 4 over 1. And 4 over 1 is 4. Now raised to power just 2. The negativity will no longer be there. And 4 raised to power 2 is 16. That's the result. So if you are given this to simplify, the result is 16. I want to believe we understand these concepts. Law of negative index. Let's move on to the next law. Law number 5. The law of fractional power tends to give us the insight into the way fractional power metamorphosizes or changes into root form. That is what we want to look into here. X raised to power 2 over 3. X is the base number with the fractional power 2 over 3. We see the 2 here as the real power. As what? The real exponent or the real index. Meanwhile, the 3 is the root element. Yes. So to say, x raised to power 2 over 3 means cube root of x. Everything raised to power 2. The numerator of the fractional power really suggests the power, whereas the denominator of the fractional power suggests the root form of the number. What kind of root will power 2 suggest? Good. Square root. Power 2 will suggest square root. Power 3 will suggest cube root. Power 4 will suggest fourth root. Power 5, fifth root. Power 6, sixth root, and so forth. So, when you see the denominator of a fractional power, that denominator tells you more about the root form of the number. Meanwhile, the numerator tells us about the power, the real index, the real exponent, which is this. So, x raised to power 5 over 2 means square root. The denominator suggests the root. So 2 is the denominator which suggests square root. Square root of x all raised to power 5. Am I communicating? And also, if you have a number like 25 raised to power 3 over 2, you have to simplify it. And you want to use this concept. There are two ways to it. You may express it as square root of 25, then raised to power 3, which means square root of 25 is 5. Then you now raise it to power 3. 5 raised to power 3 is 125. 5 raised to power 3 means 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. That is it. Or you may choose to express 25 raised to power 3 over 2 as you raise 25 in index form. So you write 5 raised to power 2. That is the 25 you have raised in index form into 3 over 2. So this 2, we cut this 2 to half. 5 raised to power 3 and 5 raised to power 3, don't forget, is 125. Do you understand? So that is that about the law of fractional power. In this law number 5, don't forget, you can use roots, you can use this other expression that I put here. You are free to use any means. Make sure you are making sense. The next law is law of product of powers. This is not that strange. It's not far from other ones we have been learning, but it has its own peculiarity. I give you this examples to illustrate the concept. Whenever you see two numbers that are in index form carrying the same power, though the base number are different, the two roots can be multiplied together to sustain the same power. This is what I mean. We have 2 raised to the power 3 times 5 raised to the power 3. Simply, without disturbing yourself, we can have 2 times 5. The power that is common to them, we put there. Do we understand? Which is 10 raised to the power 3. If we wish to leave it in index form, that's the answer, 10 raised to the power 3. And if we wish to write it as ordinary number, not in index form, we will write it as 1000. What of this? You can see that the power here are also the same, but the base numbers are different. That doesn't mean anything. We can multiply the two base numbers together, and the product will sustain the same power. Do you understand? 2 times 3, and it will sustain the same power. So this will be 6 raised to the power x plus 1. That is it. What of this? This means b raised to the power 2 has its own share of 1 over 2 as the power. X raised to the power 6 also is entitled to the power half on the brackets. So what do? We have b raised to the power 2 times half times x raised to the power 6 times half, which eventually gives us, 2 here, we cut the 2. We have b raised to the power 1, which is b raised to the power 1 times x raised to the power 3. 2 in 6 gives 3. So this is x raised to the power 3, which finally is bx raised to the power 3. b raised to the power 1 is the same thing as b. So b raised to the power 1 times x raised to the power 3 is bx raised to the power 3. In this, 2 has power 2. b raised to the power 3 also has power 2. The two of them have access to power 2. So you will write as 2 raised to the power 2 times b raised to the power 3 raised to the power 2 as well. So when two powers come together, they multiply. So, and this will be 4 times b raised to the power 6, 3 times 2. And finally, we have 4b raised to the power 6. So I think with all these, we should by now have understood the nitty-gritty of laws of product of powers, how we can maneuver the powers and the base at products.